Welcome, everyone, to Mark Voids a Warranty. That's right, it's that time again. We're going to bust something up. But before we do, I wanted to do a quick rundown of TeachMePCB. This is a 100% free web course that we are starting on Monday, right? That's just 2 days. Anyways, this year's project is this is a macro keypad. It's a little baby keyboard, and you basically go through and you can program each key to do something different. Maybe you set up an autosave routine, maybe I mean, you wouldn't make a brain board. I made a brain board, so you're not allowed to. I mean, what if yours is better than mine? But you could create a larger matrix of keys and use it for a flight simulator or something like that. And also, I wanted to let you know of something else that's coming new. I'm sorry, let me do one other thing first. Visit TeachMePCB.com. Sign up today. Now, something coming soon to Mark Voids a Warranty. I've got a new fancy microscope. This thing has adjustable zoom, which is neat, right? But that's not what makes this thing cool. Oh, no, 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 no. What makes this thing cool is this attachment. So this will go on the end of the microscope, and it creates a oblique angle view, I would say. So you screw this on the end, and normally the microscope looks straight down through the end. Then you slide it over, and all of a sudden, light hits this mirror, then it hits that mirror, and then it hits whatever you're looking at. So all of a sudden, you now have oblique angle views of whatever it is that you're looking at. Really, this thing is going to need a stand. I'm going to have to make one of those or buy one. But then we'll be able to get oblique angle views of things, and we can start inspecting solder joints, the quality thereof or lack thereof. How fun will that be? And it's got an infinity optics system. I'm sorry, I'm not more steady, but these things really do require a level of precision I just can't obtain with my hands. But infinity optics, so we can zoom in without losing focus. How cool will that be, right? That's going to be a lot of fun. So anyways, look forward to that in the coming weeks on Mark Voids a Warranty. But for now, I will set that out of the way. All right. Just to remind you, in case you missed it, in case I was talking too fast, TeachMePCB.com, and you can make your very own printed circuit board. Whatever design you want, we're going to have rotary encoders. It'll be fun. All right. Let's take a look at let me put this away real quick before I forget. Don't want anything to happen to that. That is the cool part of this lens. All right. Today we've got something that doesn't see much use anymore. We've got, let's get me on screen there, a Blu-ray disc player. Right? You don't see these too often anymore. Some people still have Blu-ray collections, but all in all, not too bad. It's got all sorts of audio out, composite out, digital, optical. Even hooks up to your LAN, your local area network. So all sorts of fun stuff to see what's in here today and see if there is anything to learn. USB, I mean, this thing has a bunch of stuff. So let's get going. Let's see what's inside. I think I need to put a couple things away there. All right, first up, we've got a couple case screws on the back here. So we're going to pop those right out. As I go through this, if you do have any questions, comments, concerns, I would love to hear from you. Just leave them right there in that little chat box. All right. So the first thing that we see here is something that looks like a traditional chassis mount DVD player. Nothing too fancy there. It does have an interesting drop front loading and unloading system. What appears to be a traditional motherboard, and then over on the side here, to keep people away from it, we've got the power supply. And it's got its own little custom case there. That's really kind of cool. I don't know that I've seen that recently. And usually when you do see them, they're metal. We've got a board in here that must be for wireless, so that'll be fun to look at. We've got a power board. Some heat sinking stuff. I mean, the possibilities are endless on this thing. Interesting thing to me is that they did build that cage around it for a consumer device where this thing would be theoretically never opened. So I don't really know why they did that, if there was some regulatory compliance that they required or not. I'm just looking for an empty bin here if I have one. There it is. Just putting those things in another bin. All right, so it looks like we've got quite an interesting connector there. We can zoom in on that in a minute. See if there's anything else. Just some FFC connectors. This one does the front panel display. This is the front panel USB, I believe. Maybe not. I don't know. We'll see. So here we've got a perforated metal shield that's protecting the logic board. So they've got a little extra space in this, and I think that was just for it to reach a standard 19-inch width. How does this come apart? I'm unfamiliar with this type of connector. And I don't want to just bust it out. Looks like this is providing some support for those RCA jacks. Okay. We are free. And power is clear. Don't really need that anymore. Now let's see if we can't figure out how to get that thing off of there. It's a nice logic board. Ooh, is it clipped in? Let's get a flathead under there and do a little bit of persuasion. Sebastian, if you're out there, I have the hammer ready if we need it. And Alex, he likes the hammer too. And Christian loves the hammer. I need a cool catchphrase like stop, hammer time. Except I can't use that catchphrase because that one's already used. All right, so I'm just removing the shield. And here we've got a spring-loaded heat sink that is just has some expanding nuts on the back side of it. I guess I could give you guys a little bit of a better look at what I'm doing. Here we go. So to get this heatsink off, there are a couple little nubbins there that catch Just going to give him a little squeeze, and that should let me pull him through the other side. If it becomes difficult at all, I'm just going to cut him off. Yeah. They're being obstinate. I'll see what happens. Yeah, Mark always wins. Remember that. Remember that, electronics. Okay, so this little, just a little 4-fin, straight fin heat sink. That's designed to use convection to pull heat away from the main processor here. Got some what appear to be memory modules. Not really sure what all this stuff is without looking up part numbers, but we might get some hints from where it is on the board and what it's connected to. All right, let's keep dismantling here. We've got our power board, micro USB. Not micro, regular USB. I see a couple of you out there watching. Is there anything that I can do to make this experience more pleasant for you? Please do let me know. I am more than happy to have a conversation with you if you like. One of the reasons that I really like taking apart these boards is it depends, but there's usually something to learn, either from people that did things right or people that made mistakes. From the level of complexity of everything that this particular device offered, the LAN, all the various video codecs, USB, I am sure there's stuff that I can learn from this board. We just have to get to the spot where we can do it. And a project this complex likely had multiple engineers working on it. I mean, there's a lot going on here. This is the control panel. More FFC cables, flat flexible connectors. Looks like this might just be clipped in. And glued in? You never know until you break something. Then you know. Okay. Get that out of the way. All that is left is freeing the drive. I don't know about you, but I'm excited. We're making decent progress here. You know what would be kind of fun? Although I don't know how we would pull it off. But if we could do a speed dismantle run, you know, like gamers do in games, just how fast can you do it? And give 3 or 4 contestants the same tools, the same devices. Although I don't know what the goal would be. Disassemble as much as possible. Have to find some way to make it exciting. Just regular old strapping tape like you might have on a box. Oh, would you look at that? I must have just done that. I just tore the FFC right there. Oh well. Got a little too excited. wanted to go fast. Look what it got me. Okay. So, get that out of here too. We have a bunch of boards, but we are not done dismantling yet. So before we start looking at these, there's more circuit boards. Do you know where they are? They are hiding in this little case here. So let's see if I can't do a little more damage. Oh, wow. How about that? Came with the free DVD. Wonder if Goodwill even knew they sold that to me. So this is Robin Williams' Comic Genius on the Oprah Winfrey Show. Okay. A little bonus there. Let's see what's next. Right now I'm just looking for other screws. This is really quite dark, so it's kind of hard to see if there are any. That was a case screw there. So it looks like the rest might just be clipped together. There are a couple screws on the back side for the motors, but I don't feel like those are appropriate to take out just yet. I kind of feel like we need to pop this thing open. Find the emergency release. Is that it? I can't see what I'm poking. Oh boy, I tell you. Normally what I do at this time, since I can't find it, and it's just something I just don't see because it's kind of dark, but normally what I would do at this point is just manually rotate the motor, but there's no way to get into it. Oh, if only there was somebody. You'll have to watch that later. Oh yes, I will have to watch the Robin Williams later. If only there was somebody out there with some advice on how I could get into this cheap plastic case. But golly, I'm just out of ideas. If only there was some tool that was sure to let me get into this. But golly, my thinking noggin's just not working today. Anybody out there in comment land know what to do? I'm not doing it until you tell me to. Okay, you're not going to watch. You're not going to tell me. I see how it is. I guess I'll just sit here futzing, wasting everybody's time. No, I'm not. I'm going to get a hammer. Let's see. What is the closest, bestest hammer? Ah, the brass one. This is the brass smash hammer. Although I'm really disappointed in you commenters. You guys should have known this. All right, there we go. We are open. See, that wasn't so hard, was it? You guys could have said that. Yes, okay, so now you're saying hammer it. Oh, you know something? It occurs to me that there's a delay on these. There's a significant delay between when I talk and when you see it. Whoops. Okay. Maybe I didn't give you enough time. My bad. So there's a lot of technology in CD DVD drives. When these things first came out, and I want to say that was the 80s, man, were they ever expensive. And they could just do one thing, you know, play CDs. CDs didn't have encoding yet. You know, MP3 players, nope. So you'd get a CD, it'd have, you know, 8, 12 songs on it, depending on how long they were. And that was it. That was it. But, I mean, these things were like, you know, $800 to $1,200. I don't even know. But they were expensive. And there's reasons for that, too. There are these focusing optics here that are suspended on these magnetic coils. See how movable that is? So it's got, I want to say, let's see, so we can go backwards, forwards, left, right, I assume a little bit. I'm getting attracted to the magnet there. Up, down. So we've got at least 4 degrees of freedom. There might be more. I'm not even sure. But getting all that thing to work is, and getting it to track the CD, man, at the time, that must have been so difficult. Now we've got the tech down pat. Specialized integrated circuits that can drive those coils. And the focusing, you know, to get that little focusing lens and laser going. But back then, this was all new. Even getting the drive to spin at the right speed, I'm sure, was a challenge. And getting the stepper motor to track. So you've got one of these one of these little round things is a laser, and one of them is a lens. And you can actually see the reflected interference patterns. And they can use that to track and guide the motor. You can see some really tiny, these little things right here are little mini micro potentiometers that they can use to adjust something in here. Maybe, probably, if I had to guess, that's adjusting the laser current and all that. Okay, so what do I need to get that free? That's part of the carriage. I just want that circuit board so we can take a look at it. I got the case screws out. Is it just held in with wires at this point? It might be just the wires. Yeah, it is. Okay. So let's free up the wires. Back to a flathead. Boy, I hope you guys enjoy Mark Voids of Warranty as much as I enjoy doing it. If you do, tell your friends, tell your neighbors, tell your friends' neighbors, tell your neighbors' friends. The more people that sign up for Mark Voids of Warranty and subscribe, the closer I get to my goal of taking apart that giant lens that sits behind me every day. Once we get to 500 subscribers, that thing's going down. Okay. Let's get this copper shield. There's a piece of copper here on the back I'm going to remove and see if that gives me access to any more wires. Never the easy way, is it? So that is serving a couple purposes. One is it's acting as a light block. You can see some of the optics here being reflected into that camera lens. So you've got some first surface mirrors. We've got the laser diode driver here and the light path. So it goes here and it hits a first surface mirror that might be a beam splitter. In fact, I'm pretty sure it is a beam splitter. So that lets some light through, but not all. Now, the light that comes from the laser and shines in the back, I doubt it does much of anything. It probably just sinks into the case here. But then light comes out here, right? So it'll go from laser, beam splitter to this first mirror, and this mirror comes out, bounces off the CD, comes back in to this second one. Then from there, it hits the other side of this mirror, again, first surface mirror, hits this mirror, and then this must be our detector. Or is it, did I get it backwards and it goes the other way? Because it looks like we have a detector here too. So one of these has to be tracking and the other one must be for thing. Okay, so if this is the laser and it comes here, goes in, out, in, up, here, back, here, through. You know something, I think I have the path backwards. I bet you it goes laser, mirror, CD, back up through here, beam splitter, sensor, sensor. That would make more sense. I bet you that's the order. I just don't know what that little piece there does. It's all fascinating stuff. If you ever have electronics that you don't need anymore, and you're an engineer, take it apart. See how other engineers solve problems. You never know what you're going to learn. Is that a security bit? Why didn't that fit? Let's try one of these. So much of engineering these days is multidisciplinary. It's not enough to just be an electrical engineer or a mechanical engineer or you know, whatever engineer. You have to have an understanding of the other disciplines that you'll be working with. You don't have to solve their problems, mind you, right? They're going to have specialized training and experience you don't. But if you have a basic idea of how things work, a basic understanding, you're going to be better off than the guy next to you. It's going to make you more valuable to your employer. And besides that, this stuff's just fun. I don't think we need that anymore. Let's get down on the ground. All right. I don't see any other screws there. Don't know if you guys do or not. So now we are we're still soldered together. Man, I feel bad for the poor factory workers that were responsible for this. That must have been difficult. Okay, so tell you what, without destroying anything, I think we'll just take a look at what's going on this board while it's on the board. And that means microscope time. Don't even have to focus. How lucky are we? So we've got some very thin flex cables here that are soldered right on the board. They didn't even bother with connectors. Lots of vias, which are good on copper pores. It helps keep things from becoming antennas. It connects everything to a common ground point. It looks too like they had some vias that they took to the other layers and they had them really close to these pins. But you can see they still left a web of solder mask to act as a dam, so the solder didn't leave these pads. That's good. a fiducial. I mean, V is all over the place. I don't like that one in the corner there. They did teardrop it, which is good, and I'm sure they had very tight manufacturing tolerances on their parts here, but let me, in fact, see if, do I have any zoom capabilities here? Ah, look who can zoom. But see, this is the old microscope where you have to focus. It's so tiring. Okay, let's, which way? This way. Okay, so here's what I wanted to show you. I assume they designed this as a class 3 device. That's my working assumption anyway. And what I would have liked to have seen is that they gave a larger angular ring, or they could have dropped the copper around over here, even without doing a full teardrop. Just bringing the copper out this way and putting a fillet in that corner there would have decreased the chances of them having to throw this board out if that drill wandered in the wrong direction. Now, these drills all look really well registered. They didn't have much in the way of observable drill wander at all, but still, you can never be too careful. Here you can see a teardrop where they opened up that trace as it transitioned from the via pad to the trace. And those are insurance against drill wander, because you don't want that drill to break out and cut the connection to the trace. That'd be bad, okay? So a lot of very, very, very small vias here, and everything's connected. I mean, it's a clean board. They obviously washed it when they were done. And lots of vias all over the place. We can't really take a look at the other side yet until I desolder those. But I don't know. There's a lot of boards to look at today, so I don't know how much we're going to get to. We'll see. We'll find out. So I'm going to set that one aside for a minute. I'm going to get rid of that stuff. Don't need it anymore. Here you can kind of see what's inside an FFC, and you can kind of see where I tore it. I must have pinched a corner there. But all these are just copper traces set between two pieces of tape, and they are fabricated in place. So down at the end, you get a stiffener with where the contacts are made. If you ever do have to design a flexible board, rigid flex is far more expensive than flex with stiffeners. So if you can ever get away with it, and it's going to depend on your application, ask your fabricator about flex with stiffeners instead of rigid flex. And you will be doing yourself a favor. All right, so let's back off for a second here, and I'll show you what I'm looking at, and then we'll go back right back to the... So here we've got the main logic board, and you'll notice that on the back side there are no parts. They would have had to solder the through-hole parts, but everything is placed on one side. So for the surface mount components, they are all on this side. And this, from first appearances, looks like a pretty decent board. First close-up that we've got, you can see that this has a kind of a gold tint to everything. So they likely did Enig. I doubt they did Inapig, but it does have a weird, maybe it's just the yellow silk screen that's throwing me. So is that a mix of copper and Enig? What the heck? I think it's just the yellow silk screen that's throwing me. One of the issues though, is when you do something like this, look at how low that contrast is. Can you read that? I can't read that, not easily anyway. Sure, with enough light, oblique lighting and whatever, I could make it out, but it's not easy. You always want to choose a solder mask that is a high contrast in relation to your silk screen color. For AOI, for placement, for inspection and rework, right? You don't want to make people too difficult, make their lives too difficult. On the back side, you can see a variety of test points. So when this thing came off of the production line, it would get placed in a bed of nails test fixture that dealt with the testing and programming, right? You can also, you always do boundary scan tests too, but that's not what they did here. They hooked these things up and went through and interrogated a bunch of different critical nets, talked to these components, and went from there. You can see that they used fiducials on a lot of these ICs. That's something you really need to talk to your assembly shop, whether they need those or not, or if you're just wasting board space. You can also see some unused connectors. Good chance those are for programming. They went ahead and did a via fence all around the edge here. And that is for EMC compatibility, electromagnetic compatibility. Looks like a little bit of hassle got on and a little bit didn't. Another unused connector. That one, based on its location, it looked like something else. I don't know what. We've got fiber here with test pads. Can you read what they say? I can't read what they say. And then a ton of through holes. So, interesting. Let's take a look in a little bit of closer look. Does look like a clean board, I'm not going to lie. Okay, so now that we are zoomed in, we can start making out what that text says. But you have to have the light at just the right angle, right? C46. Okay, that's great, but man, that stuff's hard to read. In the copper pores, where's my cursor here? In the copper pores, you've got vias tying them together. You'd also kind of want to see maybe one over here. You don't need them too close together, but you don't want to have them spaced too far apart either. Otherwise, you can end up with these parts acting like antennas, and that is bad. So it looks like they had a lot of data lines signal lines that they had to run, and just some pretty traditional routing. Looks like they were able to get it going quite a ways away. Looks like an unpopulated surface mount connector. I don't know the exact pitch, but this has all the hallmarks of like a single row, 1, 2, 3, 4, 5. I don't know. We can count that later. But it's like a single row 12-pin connector. Let's see what that silk screen is. Okay, so this is an indication of what all of the test points, I guess test points on the surface are for. Unless there's a 22-pin connector floating around. So if you were a hacker, you'd go after that, I tell you that much. Another unpopulated connector. These are the types of connectors that would maybe go there, or a single pin like a JST. Just depends on what they have connected. Let's see what we have down here. Looks like they just put a table on there and never filled it in. All right. Or no, or did they? Is this what this text is? That is allegedly a date. Okay. So this is their onboard QC check. All right. Just doesn't look very populated, so maybe they put it on and didn't get around to using it in the shop. All right, one of the ways that you can tell if you have a differential pair is, well, there's a couple ways. One, you'll see very consistent spacing, and two, you'll see quite a bit of a stretch, if these guys are any good at all, to the next closest pair. Right? So these big air gaps in between them give you a pretty good idea that we're dealing with differential pairs here. This is the IC that was underneath the heatsink, and you can kind of make out underneath the copper features that make up the connections. This is a fiducial up close. And again, maybe you need it, maybe you don't. Talk to your assembly house about that. If not, you're just wasting perfectly good board space. Let's take a look at the back side next, and then we'll move on to the power board. Nothing too exciting. It is always a good idea when you can to put all your test points on one side for the jigs. And then if you do need test points on the other side, say for bench testing, it's okay to put 2 test points on. Oh, man, that would have been handy. This is the force open and eject. I guess you short those and off you go. Or connect them to ground or power or something. I could have used that a minute ago. But see here with these copper pores, how they're all terminated with vias. That's good. Anytime you have a little peninsula, though, you should really try to run another via if you can. You never know what's going to be a resonant of some harmonic. And here we've got one of the through-hole connectors. And this copper doesn't seem like it's finished at all. So I wonder if they just did OSP. I don't know. Would have been degraded long ago. Okay, again, if you have any questions as we go through this, please do ask. Next up, we have the power board. Bum, 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 bum. Now, couple things that I don't immediately recognize that maybe you do out there in TV land. I'm unfamiliar with this. So they cut the solder mask and put these stripes through. But I don't know what they're for. I wouldn't expect for solder thieving just based on the direction. You know what it could be? I wonder if this is how they're connecting with the case. I bet you that's how they're connecting with the case to ground this board and connect it with the case ground. Maybe that's what they did. But you can see this designer used a lot of copper wherever he could. That's pretty typical of power boards. There is a big gap, and that is to separate the high voltage and the low voltage side. Or if you have two things that are at wildly different electric potentials, different voltages, you do that so that any dust or debris that starts accumulating doesn't carbonize and create a conductive path across those spots. So big air gaps are for what's known as creepage and clearance. And engineers are very, very well aware of those. But here they did it again. Green board, black text. Can you see what that is? I can't. I mean, I know it's a transformer if the light catches it right. But man, they're just making life more difficult than it needs to be. white text. Nobody's ever going to see this board, right? You don't have to make it pretty. You can tell that all of the components are on a single side of the board, mostly all through-hole components, right? Nothing wrong with through-hole components, but you put them all on one side, it makes assembly so much faster. And probably all they did was just take this, you know, with all the pins sticking through, and just slide it ever so gently through the wave reflow machine. And it just attaches solder to all those pads, and off you go. Looks like a little bit of dust and debris started to accumulate on the top of this board. That happens. It happens out in the field. That's why these spaces are so important. You don't want the that dirt to create a conductive path. Not at all. All right, we've got a few minutes left. Let's keep going. This is the connector I was complaining about earlier that I've not seen before. You've got wires that are separated by... Is that attached to the board at that side? I think it is. I mean, I wouldn't have been comfortable doing this myself. I assume these guys had tried this before. I mean, I wouldn't have put this in a production design if I hadn't used it before in something. But you've just got wire that is separated with plastic runners. But at any time, something could fall across any one of these and short out to its next nearest neighbor. So you would have to be very careful what nets you had on each one of those, because they are not spaced all that far apart. And the only thing keeping them apart are these, you know, just little bits of plastic. Man, they're brave. So they just had it soldered into one side, and then it would clip into the other. So, all right. Wi-Fi! Or USB, or both. I don't know. Interesting, interesting. So, this is a wireless board of some sort. We could use the FCC ID to look it up and figure out exactly what it is, but we don't have time for that today. So you've got a bunch of support circuitry, what appears to be a little clock of some sort, maybe a power management or a logic level converter. 4 pins are usually the hallmark of a serial interface of some sort. It could be I2C. Usually it's UART. You know, it could be SPI. I have no idea without learning more about this thing. But let's take a look. In the right light, you can see quite a few microvias. But what I'm really interested in is something I haven't seen before in antennas, and that's these. So let's take a look. Boom, 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 boom. Little music for your listening. Oh, whoa. Those aren't vias at all. What the heck? I have never seen anything like that. So you've got your, you know, your RF signal goes up and hits a, appears to be a cap. I don't know what value. That might be like a 0.1 microfarad, but then you've got this serpentine route that I'm sure is patented and is the antenna for this board. Huh. That's fascinating. I've never seen that before. And you've got a mirrored version on the other side. I'll be darned. And then these guys went absolutely nuts with microvias, creating via fences for these RF lines. So the RF line is this little thin one in the middle. You've got some components that act as a balancing network. What is that? Enhance. Oh, I wish I knew more about RF. That's some RF magic right there. We're looking down into a 2-pin rectangular package. State. And what looks to be, is that an inductor of some sort? Honestly, I don't really know. At very, very high frequencies, things behave in ways I'm not familiar with. But that is interesting. Don't know why, don't know what it is. So if you do, let me know in the comments below. But here they had copper pores again, and they absolutely tied them wherever. I mean, they just went nuts with the mouse. And that's good. It prevents that RF energy from radiating out of spots of the board where you don't want it to radiate out of. Okay, differential pair. So not the communication protocol that I was expecting. So we've got ground, differential positive, differential negative, and then a positive 5-volt input for this thing. So, I'm still fascinated by these. I don't know what those are. I mean, I know what they are. They're antennas, but absent some modeling software, I don't know how those radiate. Because usually, you know, whenever something goes back on itself, you know, it'll do a little bit of cancellation. But I mean, obviously, I'm sure it works. It's just, it's interesting to me. If you know this model and you can tell me about this antenna, please get in touch. I really would like to know. So this is Samsung DNU BS1, FCC ID, Alpha 3, Lima Delta November Umbrella Bravo Sierra 1, and then IC code, which is probably less useful, and MAC address and WPS. WPS, I thought that would be a password, but whatever. 2009, there we go. That's how old it is. And then a couple other boards. Nothing really to write home about. This was a control panel for some switches. Black silk screen on a green background. Why? You're just being mean to the assembly line workers at that point. You can see the makeouts of a hatched ground plane. That's pretty common. So if this is a capacitive touch, which I'm sure it was, if this is a capacitive touch circuit, you typically want to reduce the capacitance wherever you can, and the hatched ground planes work well for that. And then we just have a little bit of silk screen that tells us what this is, and you've got SDA and SCL, so this was an I2C with some sort of an interrupt. And taps for that so they could test it. Well, there we go. But we're not done. There's another board we haven't even gotten into yet, and that was the display. And it might be kind of fun, if I can get the right tools at some point, to just take this display apart. So we'll start off over on the side, and there you've got an IR receiver. And then we've got a little bitty display, multi-pixel display. It's got all those little individually addressable, probably in some sort of a scan matrix. I don't know what that micro mesh grid is for. But is that not fascinating? Can I get a better focus for you? So interesting, interesting. I'm sure it's a custom display, so you go out and you find the factory and tell them what you want, and they go out and they make it for you. And then on the back side, we've got ABDV out of Korea. So a custom, I'm sure, well, I don't know if it's custom, but I'm sure it pairs well with this, or it's cheap. I mean, this one's a little yuckier. I don't know if it's potted or just dirty. It kind of has the look of dirt or flux or something. Interesting, interesting, interesting. Yeah, what is that? More silk, black silk screen on a green. God, guys, you're killing me. More I2C and more. Again, the only thing you're doing by doing black silk screen on a green solder mask is pissing off the assembly line workers. You're just making their lives unnecessarily miserable, because somebody's got to inspect every one of these boards, computers too, but people also look at them and they're not going to be able to see what they're looking at. Why? Why? All right. Let's see here. There we go. All right, so that's it. That's what's left of that Blu-ray player. A surprising number of circuit boards in there. A ton of neat technology. I really want to learn more about that serpentine antenna. That is probably the most surprising part of this one. But there's a lot to learn in a simple Blu-ray player. So if you have one at home, take it apart. And remember, sign up for TeachMePCB, and we'll teach you how to make your very own keypad. Right? That's going to be exciting. So I hope to see you there. Well, that's it for this edition of Mark Voids a Warranty. Visit me next Friday, and we're going to take something apart. You never know what it's going to be, but it's always fun. And I like hitting things with hammers. It's just fun. So, all right, everyone. Take care and have a great